In other words, k times v is omega. Another problem. A wave function for a harmonic wave in a string is, this time I'm giving you the wave function, yxt equal to, that is y as a function of x and time, is 0.001 sine 62.8 plus 314t. What form is this? This is of the form yxt is a sine kx plus omega t. That means your k is 62.8, your omega is 314, and your amplitude is 0.001. Look at the information you can pick from the wave equation. Alright, find the wavelength, frequency, and the period of the wave. All that information can be obtained from these values. What is the maximum displacement of any string segment? What do you call the maximum displacement of any string segment? It's called the amplitude. And the amplitude is right here. That is the maximum displacement. Alright. A. This wave is advancing to the left. How do I know? The plus sign indicates it is advancing to the left. B. The amplitude is 0.001 meter. That is the maximum displacement. K is 62.8 Newton per meter. That is your K. What is the 314? Is omega is 314. Now K. Now is that Newton per meter? I know I told you not to confuse this K with the spring constant K, and I did actually. This K is the wave number, which is 2 pi divided by lambda. So there is no Newton there, it will be per meter. Is that right? The unit for K will be per meter, not Newton per meter. K equal to 2 pi divided by lambda. And the value of K is given to us. Therefore, lambda equal to 2 pi divided by K. And that is 2 pi divided by 62.8. And that is 0.1 meter. So the wavelength is 0.1 meter. How do we find the frequency? Frequency is obtained from the value of omega. Omega is given to be 314. And what is omega in terms of the frequency? Do you remember? Omega equal to 2 pi f. And its value here is 314. Therefore, what is f equal to? F is 314 divided by 2 pi. That is 50 hertz. So we found the wavelength, the frequency. What is the period? Once you know the frequency, how do you find the period? The period is the reciprocal of the frequency. Period t equal to 1 over f. That is 1 over 50 hertz. Hertz is per second, which is 0.02 second is the period. Well, of course we answered this already. The maximum displacement is the amplitude, which is 0.001 meter. So you can see, once you have the equation of a harmonic wave, all the information about that wave is contained in that equation. Only thing is, you need to recognize the form of the equation. It's very important. Another one. A harmonic wave with a frequency of 80 hertz and amplitude 0.025 meter travels along a string to the right with a speed of 12 meter per second. Write a suitable wave function for this wave. Find the maximum speed of a point on the string. Find the maximum acceleration of a point on the string. Well, do you remember the equation for maximum speed or maximum velocity? Maximum velocity of simple harmonic motion is a omega. And maximum acceleration is a omega squared. Well, let's pick the given data. The amplitude is given to be 0.025 meter. That is given. The frequency of the wave is 80 Hertz. The speed of the wave is 12 meter per second. Well, what is the first thing we need to find? Write a suitable wave function for this wave, which means we need to find, we know the value of A. That means we need to find the value of K and omega. Those are the two things you need, because once you have K and omega, you can write the equation of the wave. Yxt equal to A sine Kx minus omega t. Why minus? It is moving to the right. And the speed we know. So it is either Kx minus omega t or K times x minus vt. Alright, let's find some of these values. We know that v equal to f lambda. Therefore we can find wavelength. We know the wave speed. We know the frequency. Therefore wavelength lambda equal to v over f. That is 12 meter per second divided by 80 Hertz. That will be 0.15 meter is your wavelength lambda. And therefore, you can now find the value of K. K equal to 2 pi divided by lambda. And that will be 2 pi divided by 0.15 meter. That is 41.9 per meter. You can see I have got the right unit here. K, the wave number, is per meter. How many waves per meter? Alright, we got the value of K. What is the other value that we need to write the equation of the wave? We actually don't need anything more because we got the value of V. If you want to now write it off the form, Yxt is A sine K times x minus Vt. I got the value of K, I know the value of V, I know the value of the amplitude. Therefore, the equation is Yxt is A is 0.025 sine K, K is 41.9 times x minus 12t. V, the speed, is 12 meters per second. So this is the general equation for the wave that is advancing to the right with a speed of 12 meters per second. Or, if you want to write that in the form Kx minus omega t, what all you need to do is distribute that 41.9. That will be Yxt equal to 0.025 sine 41.9x minus 41.9 times 12 is 503t. This is the omega you have now. Okay, so we wrote the equation using the both forms. This is of the form K times x minus Vt. This is Kx minus omega t. And both are the same. Find the maximum speed of a particle. Now, Vmax equal to A omega. I want you to remember that. The maximum velocity is A omega. Maximum acceleration is A omega squared. So, A we know, omega we calculated. See, look at this. That's omega. Because the wave equation says this is A sine Kx minus omega t. Omega is 503. Therefore, the maximum velocity is a times omega. That is 0.025 times 503. That is 12.5 meter per second. And the maximum acceleration is, what's the equation I said, the maximum acceleration is a omega squared. Again, we know the values of a and omega, and that gives us the maximum acceleration is 6,325 meter per second squared. That's a tremendous value of acceleration. Okay, we will now talk about a very important